Okay, so let's start our very first session on backend development with a Spring Boot and Kotlin. Let me share my screen. Just give me a thumbs up when it's visible. Okay, so I think I can hear a lot of background noise. So for those, can you please go on a mute? Okay, thank you. I think it was coming from Karthik C. Okay. Let me admit the others and we'll start. Okay. Again, Nikit. Okay, please. Okay, please go on a mute if you don't want to say something for now. Okay. I think people are joining one by one, so let me admit them. Okay, fine. Okay, so we have around I think 9 participants, right? Oh, great. So today we will see highlights of what is a Spring Boot, what the overview, what are some features, and all of these things in details. Okay, so let's our approach would be a theory plus practical. So we will first see a theoretical part, we will understand the things, and then we will move on to the coding part, right? So to understand the theory, and let's first understand what is the Spring and what is the Spring Boot and all of these things. So this is about me. I'm a software developer with 5 years of expertise in mobile as well as backend development. I create open source software, writing technical content, and host live sessions as well. So we have discussed all of these things in a welcome session, right? And I believe all of you have gone through that thing. Okay, so this is our agenda for today's session. We will first see the overview of the Spring framework, then we will see what is the inversion of control, what is the Spring Boot, then what is the difference between Spring versus Spring Boot. Then we'll see the Spring Boot features, and then we'll see the Spring Boot with the Kotlin, and finally we will see how to set up the development environment. So before we start, is there anyone who has experience building with the an experience with backend development? Do we have anyone?
In 2017, I worked on REST. I created some RESTful web services with Spring Boot and MongoDB.
Okay, great. So you have worked with the Spring Boot in the past, right? Great.
Yeah, right.
Okay, perfect. Anyone else? Okay, I believe no. Okay, so Nikit has worked on it. Okay, sorry. So we will see. So in this course, we will see how to use a Spring Boot with a Kotlin to build a REST APIs. And let me clear a few things first. We are not going to build the UI for these things, right? Because this course is a focus on building API. So we will build the API, test them. I'll show you that, okay, this is correct, this is not correct, this is how it works. But we are not going to build the web UI because it's a separate topic altogether, and it could take a lot of time, and then we wouldn't be able to finish the course. So in this course, we will focus on building the APIs, right? Okay, so let's first see what is the Spring framework. So Spring framework is an application framework for the Java platform. So if you simply search on a Google, just like a Spring, you'll get this website called spring.io, and then you can see what Spring can do. It can be used on a microservice, reactive, cloud, web apps, serverless, event driven, batch. So basically it's a framework, application framework for the Java platform. So let's say why do we need this framework? It was started around in 2002. So why do we need these things? If can you build the web application with the Java using a plain old Java code and JDBC and Java Servlet APIs like those things? Yes, you can definitely build it, but it will require a lot of boilerplate code to build the application with the raw code, right? Let's say for example, those who are coming from the Android background, if you try to in Android we have a standard library called a retrofit, right, to create a network request. So if you try to do that things with the Java's HTTP URL connection class, you can make the network request, but it will require a lot of code on your side, lot of a boilerplate code on your side to create a even simple network request, right? That's why we use the retrofit. Same thing goes here. If you try to do the backend development with the plain old Java platform, Java SDK and JDK, then you can definitely do it, but it will require a lot of boilerplate code. So we wants to avoid that thing. So that's why we are going to use the Spring framework, and Spring is a very, you can say, the most popular framework in the Java ecosystem. Okay, so because it was launched in 2002, and then since then it's a widespread and most famous Java backend developer framework for the Java platform. Okay, so the Spring framework can be thought as a collection of frameworks because it provides support to various frameworks such as Struts, Hibernates, Tapestry, EJB, Enterprise Java Beans, JSF, Java Servlet, Package, Faces, etc. Okay, so Spring can be considered as a collection of the frameworks, right? Because we have a, let's say for example, we for the database access and database management, we have something called a Hibernate framework, right? Same way we have Struts. Okay, so same we have Struts, Tapestry, Enterprise Java Beans. These are all kind of, you can say, frameworks or libraries. Java Server Faces to build the UI and all of these things. So Spring is a kind of a collection of the framework. Spring allows you to seamlessly work with all of these things within the boundaries of the Spring framework. So it integrates nicely with all of these things. And to focus on these things, these frameworks create their roadmap based on the Spring framework, because this Spring framework is a very popular for the Java platform, right? Okay. So now this is the architecture of the Spring framework. At the bottom layer, we have Spring Core. Then we have Spring AOP, aspect-oriented programming. We'll see Spring ORM, Spring DAO, Spring Webflow, Spring Context, and Spring Web MVC. Okay, so let's see what all these things are. So Spring framework contains a lot of module, right? So at the bottommost layer, we have Spring Core. So what it is? This is basically the architecture of the Spring framework. So Spring Core module is the core component of the Spring framework, and it provides the IOC container. Okay, so what is the IOC container? We will see a bit later, because this is the most important concept in terms of the Spring framework. Although you are not you don't have to do anything to directly work with these things, but ultimately IOC container is what is making Spring framework popular. Okay, so Spring makes use of the IOC container, and it is a part of the Spring Core module. Okay, so IOC stands for Inversion of Control, and the second is you can see Spring AOP, right? So what is AOP? It's aspect oriented programming. So similarly, let's say we have something called OOP, right? OOPS, object oriented programming. So in OOPS, what we do, we breaks down the application into hierarchy of the objects, right? So we have classes and objects and all of these things. I believe all of you are familiar with the OOP. Okay, so I think Narendra has raised the question. Yes, Narendra.
Actually, like since I've never done a backend development before, right? I totally come from a directly into Android. So could you kind of give a I mean, correlation between like Android and Spring? So I understand that Spring is at the base level, and on top of that there are many libraries. But could you kind of just correlate it with Android, because I am a bit lost as to what do these different do. So if you could kind of correlate with Android, it will help a lot.
Okay, sure. Okay, so you can load down in your hands now, I guess. Okay, so to connect it with the Android, what we could say is to give you a rough idea. Let's say in terms of the Android, we have a Jetpack components like a view model, room, and then work manager and hilt and activity. All of these things we have a Jetpack libraries, right? So what these libraries do is it simplifies the flow to build the Android application. It's not like that without these Jetpack components you cannot build Android application. You can, but these libraries, it's a collection. Jetpack components are a collection of libraries, right? So these libraries does the boilerplate code for you and simplify the Android development for you. So similarly, you could think of Spring Framework as a Jetpack component. So this is basically a set of libraries, and you can call it a framework. So it simplifies the backend development for you. So all the boilerplate code it does for you, and it provides some nice API, so you can directly make use of. Let's say, for example, if you want to, let's say, in case of Android, let's say you want to store some data in a local database, right? So in that case, nowadays you won't use the SQLite helper and all of those classes, right? Because you have the room DB. So what room provides? Room provides an abstraction layer over the SQLite DB. So now you write the room classes, room Java, room entities, you define them, and then you simply write the insert annotation or delete annotation, those kinds of things. So you are not dealing with the raw SQL queries. Same goes for the Spring. Spring data is a library that allows you to work with the database, any database, be it a SQL or non-SQL, without even writing a single query. Okay. So you can consider Spring framework, the entire Spring framework, as a collection of the Jetpack components. Make sense for you?
Right. Thank you.
Okay, great. Okay, and just to let you know, if anyone has any question, you can simply raise your hand and we'll address it. Okay. So I'm just explaining these things. Otherwise, it's not something that very essential to start with the Spring Boot. Okay, I'm just explaining the architecture and what it consists of, because this is a theoretical part. So okay, so we have Spring Core module, then we have Spring AOP module. So we have something called OOP, right? Object-oriented programming, which breaks down the application into hierarchy of the objects. So what is AOP? AOP is aspect-oriented programming. So what it means, it breaks down the application into the aspects, or you can say concern, different concern. Let's say if you have a feature called a logging, right? You have a feature called a security. You have a feature called a maintenance. So these concerns, this concern differ from each other. Logging, security, maintenance, etc. So what Spring do is this is Spring's famous a module called AOP, aspect oriented programming. So what Spring do? Spring takes away all of these things from developer. You don't need to worry about it, and Spring will provide some nice API to build based on these things. Let's say you want to write some logging, Spring abstract away all of this lower level code, and it provide some nice API for you to log the request and response and any messages. Similarly for the security and for the maintenance and all of these things. So what we are doing, we are abstracting away the features, right? So these features is called different aspects of the application. That's why it's known as the aspect oriented programming, AOP. So this is another important part of the Spring framework, Spring AOP. The next is the Spring ORM module. ORM stands for Object Relationship Mapping. So we have a Java classes, right? Java and Kotlin classes. So and they are represented different in terms of a JVM. And let's say you want to work with the database, so they are represented differently in let's say MySQL or PostgreSQL or anything, right? So somehow we need to map these two things, this Java world and this SQL world. Somehow we need to map it. Even the room and all of these things, you can consider this room and underlying SQL is ORM, okay, because it's object relationship mapping. So what it does, it maps the Java or Kotlin classes to the database counterpart, because both of these things at the implementation level differs, right, for the JVM and for the database. So we need some applications or some libraries that map these two things. These kinds of libraries are known as the ORM module, and the Hibernate is ORM module. Hibernate is ORM framework for the Java and Kotlin. So it's object relationship modeling. So Spring ORM module is used for accessing data from database in an application. So this is a Spring ORM. Similarly, we have Webflow, Context, DAO, Web MVC, etc. So let me tell you about MVC as well. So Web MVC module of the Spring implements the MVC architecture for creating web application. So it provides a base to implement the MVC architecture for your web application, right? So these are some useful modules of the Spring framework. Okay, now coming on to the inversion of control. So we have seen that Spring Core module provides the IOC container, right? So what the hell that thing is? Let's see. So inversion of a control is a software design principle where the control of the object creation and lifecycle is transferred from the application code to a framework or a container. In other words, instead of the application code creating and managing the objects, it delegates the responsibility to a container that manages the application of these objects. So let me give you an example. So this is a Kotlin class, right? I want to show you what is this things called the inversion of control, right? So let's say we have something called a class. Let's say we have something called a class employee, right? And we have variable name string. Just give me a minute. So we property must be initialized. Okay, let's initialize something like this. Okay, so let's say we have a name and ID equal to 0. I'm just giving an example. And let's say we have something called a class here called address, and let's say where city equal to string equal to my city. Okay, so let's say we have these two classes, and this employees class contains this address variable. Okay, let's say directly let's do something like this. Okay, now let's say we have this employee class, and we have it needs an address class. Okay, so what we are doing, we are hard coding the address class as a variable of the employee, right? And you know it makes it difficult to test and pass the different implementation of addresses. Let's say in the future we need to pass the home address or a work address, and both of these things differs, right? Let's say if you have something called an interface here, address, and we have something like this. So now just give me a minute. Let's first keep it a class for now. Okay, so if you do something like this, now you are hard coding the address object in an employee, right? So instead what you should do, the ideal thing for the testing and maintainability, you should not create the hard-coded object and rather pass this object as a dependency, something like this. Okay, so you can entirely remove these things, and then while creating the employee object, let's say some from here, while creating well e equal to employee, something like this. So now, my God, just give me a minute. Now what you can do is let's say well work address. Now you can pass the different addresses for to the employee, right? Something like this. So now this address isn't dependent on the employee. Now we are controlling these things, right? We are passing this address as a dependency to this home address. So inversion of control is a software design principle where the control of the object creation and lifecycle is transferred from the application code to a framework or a container. So here we are passing this thing, and in inversion of control, we are asking the Spring framework to create an object for us and pass it to the employee. Similarly, like what Hilt works, right? You may have experience with the Hilt. So Hilt, what you do with the dependency injection. So you tell Hilt how to construct some object and pass it to the required as a dependencies. So even in this case, we are creating this object, and instead of uh, constructing the dependency ourselves, we are asking the framework to construct the dependency and pass it as a dependency. So in other words, instead of this is known as the inversion of control. And why the name? In this case, we are controlling the address, right? We are controlling the creating the instance of the address. In this case, control goes to the framework. Control is inverse, right? Control is now not in our hand. Control is in the hand of the framework. That's why the name inversion of the control. Okay. So instead of the application code creating and managing the objects it needs, it delegates the responsibility to a container that manages the life cycle of these objects. The main benefits of IOC is that it makes the application more modular, flexible, and easier to maintain. Because if you do something like this, you can pass any instance of the object, and it's a very useful in testing as well as maintaining. Now, dependency injection is a common technique used to implement the IOC. This principle that passing the requirement to a class is known as the inversion of control, and dependency injection is a technique to implement the IOC, that is in inversion of control. In DI, the dependencies of an object are injected into the container rather than the object itself creating and managing its dependencies. This decouples the object from its dependencies, making it easier to test and reuse. So again, same as a Hilt is a DI tool, right? So dependency is, you can say, implementation of this principle, inversion of control. So in this case, we are inversing the control to framework. It's no more in our control. It's in the control of the framework or container. So this is known as the principle of the inversion of control, and this dependency injection is implementation of that principle. Okay. IOC clear for everyone?
Yeah. So apart from dependency injection, is there any other way to implement IOC? Like any idea?
So this is, I think, apart from that thing, this is known as the DI. But apart from the DI, I'm not sure what it meant, because somehow this is known as the dependency injection, right? So whatever you pass, it's known as a dependency. So it's just a name given to it. So let's say you are accepting that thing, that address class, as a dependency, right? So that's why we call it a dependency, and that's why the name. But apart from DI, I'm not sure what I can refer to these things.
Got it. Thanks.
Okay. And if anyone has any like for example, somehow, let's say I'm explaining, and if you have a more concrete details on that things, you are free to raise the hand and let everyone know. Okay, that would be beneficial. Okay. So now coming to the Spring Boot, as of now we were seeing the Spring framework. So now let's see what is a Spring Boot, because we are going to make use of the Spring Boot. Okay. So Spring Boot is an open source framework built on top of the Spring framework, designed to simplify the development of the production ready Spring application with minimal configuration. It provides a set of opinionated defaults and auto configuration that makes it easy to create Spring applications quickly. So what is this? You can consider this as a subset of the Spring framework. Spring framework as a large is a, you can say, base. Okay. And built upon that base, we have the Spring Boot framework. So how it differs? So in this, if you want to build the web application with the Spring framework, that's fine, you can do it, because that's why it was created. But the thing is, with the use of the Spring framework, you have to create all of these things yourself. You have to provide the your web server. You have to provide the dependencies manually. You have to manually configure all of these things. Let's say, for example, in this case, we are creating an address object and passing it to employee, right? So in the case of the normal Spring framework, you need to explicitly and in more details, you need to tell the Spring framework how to do it, how to inject it, all of these things, right? And there are a lot of configuration in terms of backend application. There could be a lot of configuration. Let's say on which port you want to run your server, what is the username of your database server, what is the password, what is the URL, how you want to provide the logs, whether you want to write to file or you want to write to console. All of these things is known as a configuration. So if you go with the Spring framework, a base Spring framework, you need to define all of these things manually yourself, and it requires a lot of time. Okay, and it's a cumbersome. So based on that things and requirement, Spring team came up with opinionated framework called the Spring Boot. Okay, so now what they did, they provide some sensible defaults value for all of this configuration, and they called it a Spring Boot. So you can consider Spring Boot as a subset of the Spring framework, but highly opinionated. So now you don't need to worry about all of these details. And if you let me give you an example. Let's say if you want to connect with the database server, you just need to provide three things: URL, username, and a password, and Spring will automatically configure that server with Spring will automatically detect that, okay, this is PostgreSQL, this is MySQL, and it will configure your application to connect with that server. So and let's say you want to write only errors in the console. Let's say if you want to log only errors in the console, or if you want to log only warnings in the console, you can simply do it with the one liner, and Spring Boot will take care of it. So basically Spring Boot is, you can say, powerful and easy to use version of the Spring framework. Okay, it provides a set of opinionated defaults and auto configuration that makes it easy to create Spring applications quickly. Now Spring Boot also includes a number of the features and tools that are essential for building modern web applications, such as embedded server, security, data access, and more. So to run any backend application, you need a server. Okay, you need some server. We will see that thing later. But it's not like front-end application or Android application that you simply build the application and it runs. It's not like that. For the backend application, you need a server, be it a Tomcat or Jetty or Netty or anything. These are the kinds of the servers. So what this Spring Boot do, if you use the native Spring framework, you need to define your own, install and define your own server. But Spring Boot comes with the embedded server. So you even don't need to connect with their things and all of these things. Basically, using the Spring Boot is simply just like running the Android application. The same way you click on run button, it launches on emulator. So same way, if it's a Spring Boot program, if you click on run, something like this, it will spin up the embedded Tomcat server on itself, and it will start your application on that server. You don't need to explicitly define and connect that server. Okay, so it comes with the embedded server, and you can change it later as well. If you want to use a Netty or Jetty servers, you can do that as well. The second part is security. So again, that is something we will cover in depth in coming days. But let's say if you are building a web applications or web API, security is the essential part, right? Because I don't want everyone to get access to my API. I want only authenticated users. And even for the authenticated user, let's say I want to check that, okay, this is admin, provide him this much of privileges. If this is user, provide him this much of privileges. So security is essential part of the Spring web framework, and Spring Boot includes a library called Spring Boot Security for that. And the third thing is the data access. As we mentioned, somehow we need to store the data, right? Be it a user or anything. If we are creating web application, somehow we need to store the data. So that data access between clients and servers is Spring Boot has a good support for that as well. Okay. And what is the last? It has become a very popular in Java community due to its ease of use and productivity benefits. So Spring Boot provides a lot of productivity benefits as well. and as I already mentioned, it's very popular in Java community, and since 2 or 3 years it's popular in Kotlin as well, because Spring Boot has a nice robust support for the Kotlin, and it's not something like it's meant for Java only. It has a nice support for the Kotlin, and recently they have provided a very good support to the Kotlin coroutines as well, right? So definitely one thing is there, as of the current situation, the most and major projects in the Spring Boots are in Java, because Spring Boot was meant for the Java platform, but the things are getting changed since last few years, because it had the Spring team has added a nice support for the Kotlin as well. So more and more people are using Spring Boot with the Kotlin. For example, the JetBrains issue tracker system U track, right? I believe you may have heard it. Let's say if U track. So this is built on the Kotlin platform. Okay, Spring Boot. If I'm not wrong, it's built on the Spring Boot and a Kotlin. This U track project management for all your teams. So this is an enterprise project from the JetBrains. Okay, so basically what I wanted to say is a lot of companies and people are using a Spring Boot with Kotlin in production. That's why we have created this course, because if you are an Android developer, or somehow if you know the Kotlin, you don't need to learn another language, and you are fine with the single language to build the front end as well as the back end applications. Okay, now okay, so I see Narendra has raised the question hand. So is it something related to your previous question, or you have a new question?
New question actually. So
Sure.
you mentioned the server, right? So could you kind of elaborate a bit on that? That what is this Tomcat Jetty servers, and how is it different from the server we used to actually, like, we hit endpoints in Android apps, right? We click on an endpoint and we get the data from there. So in a way that is also a server. So what is a embedded difference between an embedded server and actual server? Well, the actual server as in like a, yeah.
Okay. Let me draw something for you. Let's say this is your client, an Android application, right? This is your actual server machine. Let's say this is your server machine. Now your Android application sends request to this server. This machine directly cannot accept. This is server, we call it a server, but this machine directly cannot accept request from the client. There must be something known as a web server should be running on this actual server. So web server is a program that intercept this request, and basically web server is a software program that is running on this actual server. When you have this request, when your client sends some request, this web server intercept that thing and pass it to your web application. In case we are building web application with the Spring Boot, right? So let's say this is a Tomcat. This is a very popular Apache Tomcat server for the Java. Okay. So what this server do is, this is a you can say it's just a sitting for the incoming request. Whenever we have some new request on this server, this Tomcat web server will catch that request, pass it to our application, whatever basically whatever application is listening for this type of request, it will pass to our application. Let's say it's residing here. Tomcat will pass that request that, hey, I got the request, you do whatever you want to do. Okay, so now we will process this request, we will provide some response, we will tell the Tomcat that, hey, this is the response I want to give to the client, just send it there. So what this web server will do, it will provide the response back to your client. Okay, so you can say Tomcat is sitting on this physical machine, on this server. It's a program, it's sitting on these things, and it's intercepting request and a response from the client, and whatever the response we want to send it to client. Make sense?
Right. So basically, it's like basically a layer between the, for example, the client
Right.
app and the server. And when we are connecting to the server, we cannot connect directly. There is another layer beneath it which actually acts as a mediator between our code and the server. Right. Basically, our code is in backend code. The server, there's a layer between that, which is the Tomcat or Netty, whatever server you use, right?
Right. So to clarify more on this, let's say we have learned the OSI layers, right? Physical layers and network layers, and those kinds of presentation layers, and where the request comes and all of these things, right? So as a developer, I don't care about these things, right? And I shouldn't care about these things, these layers and all of these things. So all this implementation level details, low level details is handled by this web server. You can say in case let's say in case of this is Apache Tomcat. So this Tomcat handle all of these things. Okay, I got some request. Let's extract the request body, and then let's accept from where it's coming from, what is the IP. So all of this low level details is Tomcat is getting that things, is working as an intermediate between our application, our backend application, and the client. Okay.
Thank you. Yeah.
Okay, great. So this is how server works. Okay, and thanks for asking, because otherwise I might skipped it. Okay, so you can go to this site. You can see Apache Tomcat is an open source implementation for all of these things. So in Java we have concepts called servlets and server pages and JSL and expression language and WebSockets, all of these things, right? So Tomcat implements all of these things. This servlet we'll use it later, but Tomcat implements all of these things as an internal implementation. And you might be wondering, what is this Jakarta? So to give you a brief history, all of these things, the word Jakarta, you can read it with the replace with the Java, say Java servlet or Java server pages or Java expression languages. So what happened? So Oracle gave away the Java to Eclipse Foundation, right? And due to some trademark requirements, the Java was the registered trademark with the Oracle, right? Because it is registered by the Sun Microsystem, which Oracle bought. So due to that reason, Eclipse Foundation couldn't use the Java word here, the Java servlet and Java server pages and all of these things. So starting with the JDK 17, Oracle donated the project to Eclipse. So what they did, they replaced all of the Java word with the Jakarta. Java is an island in Indonesia. Similarly, Jakarta is an island in Indonesia. So what Eclipse Foundation did is they replaced all of the Java word with the Jakarta. So let's say if you in the past in a Java EE means, if you see something like this Java EE, you can see here Java EE platform. So EE simply means enterprise edition. So in the early days, we have something called the Java EE Enterprise Edition to build the web applications. Okay, so the implementation of the JEE become the Jakarta EE, right? Because Eclipse couldn't use the Java word here, so they replace Java with the Jakarta, and they replace all of the packages as well. So let's say, for example, Java. To give you an example, those who are in Android development, if somehow your hilt or a dagger move to the JDK 17 plus, is let's say if you use something like Java X dot just give me a second. Let me get the whole package name. Hilt inject. Just give me a minute. I'll show you what is the difference using a dagger. I just wanted to see the whole package name. Okay, and before, like all of you are Android developers, or is there anyone who is not familiar with the Android? Can anyone provide me idea on this? Hello.
Yeah, you're audible. I guess everyone is Android. Yeah.
Okay, great. You something called inject, right? In a hilt and dagger. So the implementation. So the import is a Java X dot something like, let's say something dot inject, something like this. So when Tiger will move to the Java 17 plus JDK, what they have to use instead of this Java X, they have to use the Jakarta X, something like this. Okay, because Eclipse Foundation did change the package names as well. So your Java X will become the Jakarta X, something like this. Okay, that's why this name Jakarta, because initially it was known as this Java Servlet and JSP and all of these things. Okay, so that's a bit off track to the course. Okay, so now coming, we have cleared the server part, right? So now let's move on to what is the difference between Spring versus the Spring Boot. So in terms, there are lots of difference between Spring and Spring Boot. Although Spring Boot is a subset of the Spring, there are differences that makes Spring Boot ideal for quickly build the websites or APIs, quickly build up and running. Okay, so the first is in terms of the configuration. Okay, so in the Spring, you need to create your configuration files and you need to manually write the configuration for each of these things, be it a database or logging or anything. Okay, database, logging, server ports, when to run this application, all of these things you need to manually configure it, and there are lots of boilerplate code. With the Spring Boot, we have something called auto configuration. So with some sensible defaults, it will automatically configure your website. So to give you an example, just provide your database name, username and password, and it will automatically connect your web application with the your database server. So we have something called auto configuration in case of the Spring Boot. The second is dependency management. In Spring, we can use we have to use a manual dependency injection. And in through the Spring Boot, we have something brilliant concept called the Spring Boot starters. Okay, so what the starter packs are? So this starter packs provides ready to use the dependencies, ready to use the codes that you can quickly use to build your application. Let's say, for example, if I want to connect with the PostgreSQL server and I want to write some insert query, so we have something called Spring Data Starter. Okay, Spring Data Starter. So this is starter dependency. So with the help of this dependency, I don't even need to write the query myself. Okay, I can just, we'll see these things later. I can just name my method, my function suitable for that thing, and it will automatically insert or delete data to my database. Okay, I don't even need to simply write a query. So let's say in case of a room, you need to write some query to retrieve the data, right? Here in the case of the Spring Data, you don't even need to write the queries. If you write the method name in such a way that it will automatically retrieve the data, along with the a perfect support for the pagination and sorting and all of these things. So we will see that things later as well. So you can say the starter dependencies are a very special that makes Spring Boot unique. We have dependencies for starter security, starter data, starter NoSQL and all of these things. Okay, so basically all of these starter packs, we will see that thing. The fourth point is, third point is embedded server. So in case of a Spring framework, you need to manually install and connect with your embedded your server, basically in case of this Tomcat, Apache Tomcat. But in case of Spring Boot, it comes with the Tomcat as well, and you can use a Jetty or a Netty as well. Okay, basically Netty is a coroutine backed server, I believe. Sorry, it's a asynchronous server, Neo client, because okay, so Netty is asynchronous and event driver network application framework. So we have something called Jetty, we have something called a Netty, and we have embedded. So by default, Spring Boot provides the Tomcat server as embedded. It embeds this inside the Spring Boot. Okay, so this is about the embedded server. The fourth point is the development time. For the Spring, it requires significant setup and configuration because you need to manually do everything on yourself. And in case of a Spring Boot, it's a quick setup with a minimal configuration required. And the final point is about the deployment. Let's say you have wrote the code. Now what to do? Now now what to do? Let's say you want to deploy it on your server, on your AWS or Azure or Google. So what to do? So with the Spring, you need to set up server, basically this web server and all of these things manually yourself. With the help of the Spring Boot, it provides embedded server, so you can directly run your application as a jar file, as a single executable. You can create a simple jar file. It will contain the Tomcat as well. So if you double click on it, it will simply run your web application, and you are good to accept the request from the client. Okay, so that is a major benefits of using Spring Boot over to Spring. Okay, so now let's see what are some features provided by the Spring Boot. So the first is the auto configuration. We have discussed Spring Boot provides a set of opinionated defaults and auto configuration that eliminates the need for extensive configuration, making it easy to get started with the Spring. Basically, it auto configuration the things with the opinionated defaults values. Again, second is a Spring Boot starter. We have already seen starter projects are pre-configured templates that provide a set of dependencies and configuration for specific use case, such as web application, data access, testings, and more. The final is embedded server. Spring Boot includes embedded Tomcat, Jetty, or Undertow server, which makes it easy to deploy Spring application as a standalone jar files. If you create your application in a Spring framework, you cannot deploy it as a standalone jar file. So for those who don't know about the jar file, basically it represents as a Java archive. Okay, it's a fed jar, or we can call it a fed jar. So jar file, not about jar app. Okay, so jar is Java archive file, is a package file format typically used to aggregate Java classes into one file. So in this Android, we have something called APK, right? Android package. So what it does, it contains all of these resources and code and all of these things in a file called APK. So similarly for this Java files, we have something called a jar package format, Java archive. So it contains all of this metadata and code and resources and packed into one file called a jar file. So with the help of the Spring Boot, you can create a single jar file and you can quickly run it as well, which you can't do with the Spring framework. Okay. So another good feature is a production ready feature. Spring Boot provides a set of production ready features such as health checks, metrics, and monitoring that makes it easy to manage and monitor Spring application in a production. So building web application is not just about the building. You need to monitor as well, right? Let's say if I had created an application that connects with my post database. So I need to make sure that at all of time my application is connected with the database, because somehow, let's say connection is lost, let's say database server is down. Okay, things in terms of the backend development. Let's say database server is down. User from the client side or from the Android application side, user is requesting some data. If my database server is down, my Spring Boot application won't be able to fetch the data, and it will return an error, right? And this will harm our reputation as well as our functionality. So this shouldn't be done. So for that things, monitoring system should be in place. We need to constantly monitor that, okay, DB server is running, this resource server is running, authentication server is running, all of these things are running. So we need to monitor that things as well. So Spring Boot has a good support for monitoring as well as managing these kinds of things in production. Okay. And another very useful things from Spring Boot is called actuator. So Spring Boot actuator is a set of endpoints and tools that provides operational insight into Spring applications such as health checks, metrics, and more. So now let's say Narendra, just give me a minute. I think two people has raised the question. Just give me a minute. Okay, so what is actuator? So actuator, when you comes as a different dependency to your Spring application. If you include this dependency, what it does, it provides production ready supports, like it provides some HTTP endpoints that you can hit to know that, okay, my application is running, all database are connected, everything is fine. What are the current use, what are the load on my application, whether it's a fine or not, whether all of these things are working good or not. So all of these things will be available via endpoint if you use this actuator dependency in a Spring Boot. So this is a very important feature of the Spring Boot. Okay, now before we move on to with the Kotlin part, let's address the question. The first is from Narendra, and the second is from the Nikit. Okay, Narendra, then you can ask.
Yeah, so basically I'm just trying to wrap my head around it. So if we kind of think of the backend as basically there is a database where we are actually storing all the data that our app would we would write code to access and manipulate, right? So basically when we what we are basically exposing are endpoints which is being used by Tomcat to kind of expose so that clients can handle it, right? So basically this database that we use, that is it's another server that is like, so when we make a connection with a database, right? So like I'm trying to understand that how does your backend server and a database server, like how do they connect between each other? Like what is the mode of communication between backend and database? Like I don't want to like go into the like explanations of it, just kind of how it does that basically.
Okay. So regarding
Right,
to
I'll
answer
give
your
you an
first
example. I'll
question.
give you an example.
Sure.
For client and server, it was client goes to this web server. Web server kind of translates it to kind of access the code that we have written, right? So how is it for the database in the backend?
Okay. So for the database, it differs via DB to DB. But let me give you an example. Let's say we are running Postgres here, right? It's basically, yes, you can say a better version of MySQL. Okay, let's say we are running PostgreSQL here, and this is a database. So by the database server, I didn't mean a another server machine. It might be another server. Let's say there might be cases, and in case of a most production application, the database server is different than what this server is. Okay, but in our application, both of these things will reside here. Okay, our database server and our backend application will reside inside a same machine, something like this. So what is the database server? By the database server, I mean that when you install the PostgreSQL, it creates a daemon process. Okay, those who are not familiar with this daemon process, is the daemon process is basically a long running process that watch that. Okay, do anyone is asking to put it simply, a daemon server will run, and it will watch that, hey, anyone is requesting for my service, do anyone need my help? So this service will keep running continuously in the background. Okay, so when you install the PostgreSQL server, it creates a daemon process called a database server. Okay, so it in that sense, this process is a server is looking for the incoming connection from the client. For this server, who is client? Our application is client, right? Because we are sending we are asking the data from the database server. So from, let's say we have a request from the client that give me some data. It will come to the Tomcat will give it to us. Now we will go to the PostgreSQL asking, hey, give me this data. So PostgreSQL has something called a process running as a daemon process, and that daemon process will notice that, hey, this let's say my good app, hey, it will notice that, hey, this application needs something from me. Okay, let me go and fetch that. So it will go to its database implementation, basically rows and columns. It will get the data, and it will provide to the my good app. Unlike this connection, this is HTTP connection. So it is when the request finish, this connection is terminated, right? When you so I'm not going into details of the network request, but when you make a network request and you get the response, the connection is closed. Basically this connection is closed. So okay, HTTP will close this connection. Okay, and retrofit, and ultimately okay, HTTP will close this connection. The same thing is not going here. Because why? Because it's a not efficient to make a connection to the database from our application on each request, because on the backend we might need to make a thousand hundreds or 1,000 requests per second to database server, right? So it's not ideal, sorry, ideal and good to close this connection on each request. So how this works, basically we first initiate the connection from our application. This is the implementation details, and you don't even know that these things is going on, but I'm just explaining that when we first create from our Spring Boot application to PostgreSQL server, this connection will be kept alive. Okay, this road. Okay, let's consider this is a village. This is a village. This is a road to transport the goods between these two villages. So this road will be kept alive. This flow will kept alive, and it won't be terminated. Something like this. So we can provide a timeout that, hey, I want this flow to be alive for a minute or for 10 minutes, or let's say for 30 minutes. Okay, so that things we can specify, and this till that timeout, this flow will remain active. So for each subsequent request, you don't need to create a new flow with the database server. You just have already created connection, right, with the database server. So you can simply pass your request to on this path, something like from here to here. And so you don't need to manually create these things each time, which will save you a lots of resources and times and memory and CPU resources as well, right? So this works on a basically inter-process communication. If it's in a same CPU, it's an inter-process communication. Now let's move these things out of picture. Let's say this is our DB server running on, let's say this is on Azure and this is on AWS, something like this. So let's say this is on a MS Azure platform. Okay, so we have this server. Inside the server, we have PostgreSQL database server running. So now this request would be from this server to this server. Sorry, and again we can keep this connection open, because this is database server and we don't want to close this connection on each request. So we can make this connection open for a longer period of time, let's say 1 minute or 5 minutes or that kinds of thing. It's not something like that we will connect is in a 1 milliseconds or 1 seconds, etc. Okay, so this is how this backend application and this database server communicates. And to give you more idea about the daemon, in Android application, when you start your build, you might have seen in the locate that starting Gradle daemon, right? You might have seen this line, starting Gradle daemon. So what this does, now your Gradle is starting a daemon process. What this daemon process is, this process will sit and wait. Hey, do anyone is requesting for me to build Android application? When you hit the run button, daemon will notice that, okay, I have some request, let me build the Android application. Once the build is finished, your application is uploaded to the emulator. Now this daemon process will not shut down, it will just sit and wait. When you rerun the application, now this time you don't need to recreate the daemon process, right? Because you have already created it. So now you have the added benefit that it will save you some resources and time as well, because starting a daemon process might take some time, but if you have some process running, then you can continue from the next subsequent task. So you can understand the daemon process with that example in Android as well. Basically Gradle start the daemon, and this is how DB communicates with this our application. Make sense for you, Narendra?
Yeah, thank you.
Okay, great. Okay, Nikit has some question, I believe. Yes, Nikit.
Yeah, Rajesh, my query is related to packaging, right? We have two ways to create the packaging, jar file and var file. So where we need to create the jar file and where, in which scenario we need to create the var file? I mean, my query is related to that.
Okay, so let's say if you let's say we have something like we are using the Spring Boot, right? And and we want our application, we want to deploy our application as a single click installer. Let's say when I double click on the jar file, it should start it should start running my application. So jar is a single executable, right? So when you want that things, usually with the Spring Boot, you need to create a jar file because it's a self-sustained application. It contains the embedded server as well. What is a var? In case of a var, let's say you have var file. So var file needs a server. Okay, it needs a separate server. You have, let's say, if you have a Tomcat server or a JBoss server running on your server. Now you create your var file. You put that var file. You give that to this web server. That hey, this is my var file, and run it. Basically, you want to configure the most aspects of the web server. You want to define how many connection you want to catch. You want to define what should we do when we have this kinds of a request, what should we do when we have this. Basically, when you want to play with the low level these things. Okay, now you will use a separate server. And let's say you are not satisfied with the Apache Tomcat. Somehow you are not satisfied with the Apache Tomcat, and you need a more performance server. And you choose for the Wildfly. The Wildfly is a web server. Okay, it was formerly known as a JBoss, and it's developed by the Red Hat. So you have this Wildfly server running. Okay, now this Wildfly cannot run your application directly. So you need to package your application in a var format. You give it to the Wildfly that, hey, this is my application, run it. So Wildfly server will accept that. It will run the application, and now you are good to accept the connection from the client.
Okay, making this.
Okay. So you can see more on this as well. Are you only use for the web applications, and you can give it to the server as well. And for the jar is, you can say, self-sustained. You can simply run it on its own. Okay, and one thing to note, it's not like that. Okay, you can create jar files for your web application. You can simply create jar file for any Java program. If it's a simple command line, let's say I have this program, something like this. Let me clear all of these things. If I have this program like this, I can create jar file based on this as well. So now when I create a jar file, it will create a file, and then I can simply double click on that file, and it will similarly, let's say here, what it will do, it will open a terminal, right? It will print something on a terminal. Let me run it. Okay, it's simply printed on hello world here terminal. So if I create a jar file based on this program, it will simply open my terminal console and print this line. So basically, jar is a packaging format for the Java classes. So it's worth to note that it's not about a web application only. You can create a jar file based on the any Java classes for that matter. Okay, great.
Thank you.
Yeah, welcome. So now, okay. Okay, so if I answered your question correctly, just load down your hand, because it will help me to differentiate. Okay, Narendra, you have another question? Okay, great. Okay, here's load down hand. Okay, so now let's focus on the Kotlin part. Okay, why Spring Boot with the Kotlin? Because Spring is excellent in Java. Why do we need this in Kotlin? So these things you already know. It's a concise syntax. Kotlin's concise syntax reduce boilerplate code and makes the code more readable and maintainable. I believe all of you are familiar with the Kotlin, so you can understand these things with even without more explanation. It's a null safety. Kotlin's null safety features eliminates the need for null checks and make the code more robust and less error prone. Functional programming, Kotlin's functional programming capabilities make it easier to write clean, composable, and testable codes. And interoperability, Kotlin is fully interoperable with the Java, which makes it easy to use with existing Java codes and libraries. These things are simple to understand on its own, right? And all of you are being a Kotlin developer, you know these things. Okay, so now another major benefits of using Spring Boot with the Kotlin is we have coroutines in Kotlin, right? So in a Java world, we don't have things like coroutines. So and see, this asynchronous backend programming was the need of an hour, because you cannot simply make a synchronous request with your backend framework, and it will take time. It will block the threads, and once the response is available, it will deliver the data. So you will in that case, you will need to create a thread pool, and you need to use a lot of a thread, right? So to handle these things, I'm just giving you a rough idea. Spring Boot introduced something called a based on the project reactor. Okay, let me give you an let me give you an idea. So if you go to the Spring side, what you can see it's a reactive option here, right? So Spring's asynchronous non-blocking architecture means you can get more from your computing resource. So the Spring Boot that we are going to have a look is a non-reactive. Okay, we are not going to use a reactive because this is the different things altogether, and it's not a part of this course. You can definitely check out these things on your own. But to meet the demand, Spring has provided support for the reactive using the something called a project reactor. We have these things called a project reactor. If you go to this his site, you can see reactor is a fully non-blocking uh, uh, and provide efficient demand management. It directly interface with the Java functional APIs, completable future streams, and all those things. So basically, this is about the non-blocking code. And Spring Framework makes use of this project reactor to create a reactive web application where you can emit the flow of the data without blocking the threads and all of these things. We have something called a mono and a flux in this reactive application in the reactive web development. Okay, we have something called a mono, two things, mono and a flux. Okay, so this is part of, you can say, project reactor. Now if you use the Kotlin, you don't need to use these things, project reactor and all of these things, right? Because Spring Boot has excellent support for the coroutines, and coroutines are a non-blocking, right? So you don't need to use this mono and flux and all of this blah 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 things. You can simply make your function suspend, and Spring will make sure that it runs on a background coroutines. Okay, it will make sure it will run on another coroutine. So you have nice reactive support as well. We are not going to implement that things, but you can have a look. Okay, so this is another major advantage of using Kotlin with the Spring Boot. You are good to go with the reactive web application simply using the Kotlin's coroutines. Okay, and Spring Boot provides excellent support for that as well. It's not you can say 100% support, but it has a nice excellent support in a Spring Boot. Okay, so this is another advantage of using Kotlin with the Spring Boot. Okay, so now today let's see how to start our development environment, because the today's session was mostly focused on the theoretical part, and from the tomorrow we will see how to use the coding part, and we will understand different concept along with the code as well. So how to set up the development environment? You need to install.
I have a question. So I have raised my
Yes,
hand.
Srikant.
So,
Yes, sure.
coming in the Android point of view, we say asynchronous because there is one main thread running, and if anything has to be happen in parallel, like we do a asynchronous, right? So in coming to backend, if you say it as a coroutine for a background or other thread, so we mainly use for multiple computing things at a time. That is the only requirement, right? Or are there any other requirement?
Requirement in terms of, see, these coroutines and all of these things. Let's say if you let's focus on Spring Boot normal without coroutines. So how it will work? There would be one thread that you can say dispatcher thread. In Android you have main thread, right? And this main thread shows the UI, and if you need to make a network request and all of these things, you need to use the background thread. So in Spring Boot we have one main thread called, let's say, dispatcher thread. What it's the sole task is what? Whenever we send some request to our web application, it will dispatch that application through another thread pool, and it will say that, hey, finish these things and provide the response to this guy. Okay, so basically it is dispatching the request to another threads. Okay, so we have one dispatcher thread, and it's dispatching the request and response to another threads as well. So that is the flow with this Spring Boot, regular Spring Boot without the coroutines. But if you use the coroutines, you can provide support for the reactive web application. Let me give you an example. Let's say, okay, let me give you an example. Let's say this is a Twitter just give me a minute. This is a Twitter application, and if you might have noticed, let's say this is a tweet, and here we have different components called likes and comments and uh, bookmark, etc. Right? So if you notice these things, this likes count is updating in a real time. Okay, it's updating in real time. If you are on the same page, and even if you don't perform any refresh, whenever someone else like this tweet, the like counts will be updated. That means what? It's connecting with its server, and in the server is sending a flow, basically constantly sending the updated number of the likes to these clients, right? So if you do that things with the regular Spring Boot, now your the thread, main thread that handle this dispatch, this request and response, will be blocked, because now your thread is focused to the one client, that hey, send this constant stream of data to this client. Now it will be blocked. To avoid that things, we have concept of this reactor, reactive web application. And if you use the coroutines, you can send a stream of the data or a flow of the data without blocking that main thread. Okay, so this is how it works in the backend side. You have your backend server here, you have your let's say dispatcher thread here, and your application is running. So now your dispatcher thread can send a stream of the data without blocking the other incoming request. Let's say while I'm delivering this request here, other clients might be sending some request as well. So this can accept this as well, and it can provide a stream of data via another coroutines to our client. Okay, so this is how it works. This is how it works in a reactive world. So if you use the project reactor, it makes use of the Java APIs like a stream, completable futures, and it provides two main things. The one is a mono, and the second is a flux. So mono is basically a single item, and flux is a stream of the data. If you want to send a single item to your client, you just wrap it inside the mono. And if you want to send a stream of the data, you wrap it inside the flux. So if you search for that, it's coming from the reactor library. So flux is a publisher. Okay, so mono means a single or an empty value, and flux means a list of the data. So this flux you can consider as you can just consider this as a Kotlin flow, right? Because flow is a list of the data. It emits the data. So you can consider this list as a flow. So if you use the project reactor, basically the Spring reactive with the Java, you have to deal with this mono and flux. You have to wrap your response. Let's say I want to send my user response at a one time. So I need to wrap it something like a mono user, right? And let's say I am sending a list of the users. So I need to wrap it something like a flux of the user. So this is a list, and this is a single item. If you use the coroutines, you can avoid all of these things, because if you want to simply emit a user, you can create a suspend function, send user, and instead of wrapping it inside the mono, you can simply write something like this. If it's a suspending function, Spring Boot will automatically send a one user, right? You don't need to wrap it inside the mono. And similarly for the stream of the data, you can use a flow as well. So this is how it works with the Kotlin coroutines. Okay, it has definitely more things attached to it. It's not something like simple it is, but to simplify it, I've given this example. Okay.
Yeah.
Okay. Okay, now to set up the development, what you will need a JDK. You will need to install the JDK on your machine. Okay, if you use the IntelliJ IDEA IDE, let me give you an example. So you can automatically it will prompt you on a first run. If you don't have a JDK installed, you can either manually download JDK, or you can download it via the IntelliJ IDEA, right? And even for the JDK, there are lots of implementation. Amazon Corretto, Open JDK, Eclipse Temurin. So if you just search for the JDK, there are lots of implementation. One is from the Oracle, because see, Java JDK is a specification, right? And it says that, hey, implement these things and these things and these things. So now there might be multiple implementation. One is from the Oracle, one is from the Amazon, one is from the Eclipse Foundation, one from the Azul. Okay, so from the Amazon, it's called Amazon Corretto. So this is the JDK implementation. Okay, so Amazon Corretto is a production ready distribution of the Open JDK. We have something called Open JDK directly coming from the Open JDK org, and based on that things, we have something called Amazon Corretto, right? Similarly, we have something called Eclipse Tamarind. So it's it's a JDK implementation of the Java standard APIs. We have something called Azul Zulu as well. You can see Azul Zulu SDK. So again, it's an implementation of the Open JDK. So these things differ in terms of the coverage they are providing to the Java application, what Java JDK, what are the supports they are providing, whether they are paid or not. Because definitely if some JDKs are paid, that means they will provide support for this JDK as well. As a single developer, you don't need these things, but if you are, let's say, organization, let's say a TCS or Google or something like that, you will need support for from the JDK team as well, right? So there are a paid implementation of the JDK as well. In our case, you can simply use the Eclipse Tamarind because it's coming from the Oracle, because they have provided the things to the Eclipse, right? Now Eclipse is maintaining this JDK. Sorry, this is the implementation of the Adopt Open JDK, I believe. Yes, Adopt Open JDK. Yeah, so Adopt Open JDK donated this project to the Eclipse Foundation. And you might be wondering that, okay, this guy is repeatedly telling that Eclipse Foundation is this and this and this. So what is this? So basically, this is a foundation that hosts lots of the programs. You might have heard about the Eclipse only ID, right? But this is just a one part of this Eclipse Foundation. It's a very large foundation. It hosts the Eclipse IDE, it hosts this Tamarind JDK, it hosts this Java Enterprise Enterprise Edition as well. So they contains hundreds of the projects inside just one foundation, similar to the Linux Foundation. Okay, so for the implementation, we will use the Eclipse Tamarind, and you can simply download it here, or you can download it based on your platform, be it a Windows or a Mac or a Linux. Okay, you can do something like this, or you can simply download the JDK from the IDE as well. If you go to the settings, if you go to the Gradle, and if you go to the Gradle JDK, something like this, sorry, Gradle JVM, here you can see the download JDK option, right? So it will fetch the list of the JDKs. You can see what do you want to download: Eclipse Tamarind, Oracle Open JDK, SAP, even SAP provides the JDK implementation. Azul provide that, Graal VM provide that, IBM provide that, and Amazon Corretto as well, right? So what we want the JDK 17, right? So because JDK 20 is latest and the JDK 70 is the has the long-term support. So we will use the JDK. I'm not going into the details of these things. You can explore this, what is this long-term support and all of these things. But this JDK 17 has a long-term support. So you can use this Eclipse Tamarind Open JDK architecture 64. Okay, and it's based on the hotspot VM. Okay, so the JVM is named as a hotspot in case of this Adopt Open JDK. You can simply download it. Okay, so I have downloaded something like this. So now you have your JDK ready, right? What else? You'll need an ID. Vaibhav has question. Just give me a minute. Okay, so you need an ID. So for the ID, a lot of you may ask about me that how to get the free IntelliJ IDEA, right? So to put it simply, if you want to do Spring Boot development with the Kotlin, the best ID is of course IntelliJ, right? Because I've never seen the ID better than IntelliJ in my in my entire career. So you can simply use this one. and it has two editions. One is a community edition, which is free, and the second is ultimate edition. So with the community edition, you have access to if you go to their website, IntelliJ IDEA edition, you have access to Java and Kotlins and all of these things, but you don't have direct support for the Spring Boot. Okay, you can see on the community edition, and on the, you can see the Spring Boot part, it's not ticked here, right? So it's in the IntelliJ IDEA Ultimate. So community has these features, something like this, but not this. These are under the IntelliJ IDEA Ultimate. So what you can do, the Ultimate provides a 30-day free trial. So we can, you can, our course duration is 3 weeks, right? So what you can do, you can download this Ultimate Edition, register with your email address, and get the 30 days trial. So now you will be follow along using the Ultimate Edition. And let's say if you want to later somehow practice after the course finish, you can continue with the Community Edition. It's okay, but then you need to write the all the codes manually yourself. IDE won't help you, right? So this is the case, you need to deal with it, and I can I cannot do it anything. Okay, the if you don't want to go with it, there is a Eclipse as well as the NetBeans. They have good support for the Spring Boot, but again, not the perfect support for Spring Boot with the Kotlin, the same as the IntelliJ IDEA has. So this is the perfect thing. What you can do is you can get it for a free trial. If you like it, you can purchase the license as well. And otherwise you can go with the community edition. Okay, and someone asked about the large organization. So in large organization, yeah, they definitely buy the license per user for the IntelliJ IDEA for the Spring Boot development as well. Okay, and if you use this IDEA, you will have support for other frameworks as well, like a Micronaut, Quarks. So these are the backend development framework, just like a Spring Boot. Okay, it's called a Micronaut and Quarks as well, and they have Kotlin support as well. And then we have something called a Ktor as well, that is a native Kotlin backend framework. Okay, so now we have the IDE. Now before we move on to the creating projects, okay, I would like to answer Vaibhav's question. Yes, Vaibhav, please.
Can't we directly use the existing Oracle JDK?
You can use, you can definitely use the Oracle JDK as well, but it just depends on the preference. I just download the Eclipse Tamarind. You can definitely use the Oracle JDK as well.
Okay.
Okay, and even as a single developer, or even as a little team, this won't even make the JDK won't even make the difference. It makes a difference when you have that large team and you have to comply with audits and all of these things, and then you need some features that are provided by some JDKs only, let's say tracing and a flight reporting, and you can see profiling, you need to profile as well. So some JDK provide the support for that things as well. So that is something you, as a solo developer, you don't need to worry about. You can simply grab any JDKs and you are fine to run your application. Okay. Okay, now let's see how to create the actual Spring Boot application. So to do that, see, here comes the difference between Ultimate and Community Edition. Let's say I am on a Community Edition, right? Because sorry, Ultimate, because I have the license. So what I simply can do, I go to File, New, and click on the new project. Okay, here I can see the Spring Initializer. Here from this IDE only, I can create a Spring Boot project. If you have the Community Edition, you won't have this option, right? So what you can do to create a Spring project, Spring provide a website called a Spring Initializer, start.spring.io, right? So you can go to start.spring.io, something like this. It's a Spring Initializer. So now we can select our build system. We will go with the Gradle using the Kotlin build script. So we will select this option. What is the language we want to build this in a Kotlin, right? Definitely. So we'll select the Kotlin, and which Spring Boot version you want to use. Let's say we want to go with the latest table. So it's a 3.0.5, right? And the one thing to note, the Spring Boot version 3 made JDK 17 as a baseline. So if you use the 3.x version of the Spring Boot, you cannot use a JDK below 17. You cannot use JDK 15 or 16, right? You must have to use at least JDK 17. So because this is the requirement for this thing. And if you go below 3.x, be it a 2.7 or 2.7.10, you can use JDK 11 as a baseline. Okay. And but if you use the 3.x, then JDK baseline is 17. Okay. Now you can provide your group name here. Basically, in case of a Android, we have package name, right? So similarly, this is a package name. Let's say com.hadia Rajesh. Then let's keep it a demo. My artifact is a demo. So what is my package name? com.hadia Rajesh demo. So this is a project name. So let's call it a demo, something like this. And demo project for Spring Boot. What you want to package? We want to package it inside a jar because we want to make it self-sustained. Which Java? You can see 17, right? If I select something like this, you can select it, but you cannot run it. If you use 3.0x, you must have to select the 17. Okay. Now, what do you need to do? We have selected the configuration. Now we need some dependencies, right, to run the actual Spring project. So go to this portion, click on add dependencies. So now what we want to build some APIs, right? So to provide the minimum support, we need this things called a Spring Web dependency. What it is used for, you can see the description here. Build a web including the RESTful APIs application using the Spring MVC. Uses Apache Tomcat as the default embedded container. So if you click on it, now your Gradle file will contain this dependency. You can click on explore, something like this, and you can see your Gradle file contains this dependency called a Spring Boot starter web. Right now, see, it's a starter I was talking about. So starter as you can say a very good starting point to start anything, be it a database or a security or web application. So now as a base, what we want to do, we want to build our web application, right? So we need a controllers and we will see repositories and all of these things. So for that, we need to implement these things, a Spring Boot starter web. Okay, we have this Spring Boot starter web. What is this next thing? JSON. So this is a JSON serialization and deserialization. Okay. So in case of Android, you may have used the Motion or sorry, I mix up the things. You may have used the Moshi and a JSON, right? So in case of a Spring, it's a JSON. So again, JSON is the JSON deserialization and serialization library for the JSON. Okay, so Spring Boot makes use of the JSON. And it uses Kotlin reflection APIs as well. Reflection, I wrote a detailed Instagram post, so you can go and check out on my profile, right? And for the testing, it provides this dependency, right? And this is the standard configuration. Okay, this is the Gradle file. Now let's say I want to connect with the PostgreSQL database. So what I need to do, I need to use a PostgreSQL driver, right? So if I select them and if I go to the Explore, I can see that Spring Boot has added this dependency. Instead of the implementation, it has added the dependency as a runtime only, and this is the PostgreSQL driver. Let's say if I want to work with the JPA, we will see what JPA is. Basically, it's for a Java persistent API, and it makes working with the database really easy. Just a piece of a toy. Okay, if I want to include that thing, I go to Explore. I can see new dependency is added called a Spring. Where did that went? Starter actuator web data. I think it's for the Spring data. Yeah, Spring data JPA. Okay, yeah, I forgot to add that. Okay, if you use the Spring data JPA, you can see the starter pack for that as well, right? You can see Spring Boot starter data JPA. So this starter will allow us to quickly connect with the database that support the JPA implementation, Java persistent API. Okay, so once you have all the dependency, you can manually add them later as well. But as a starting point, you can do something like this, and then you click on generate. So what it will do, it will download a zip file, right? Something like this. It downloaded a zip file. If I go to the Finder and if I go to the downloads, I can see where is that things, demo.zip. Sorry, let me go to the download, right? So I can see demo.zip. I can extract is, I can archive utility. Okay, so I can definitely extract, right? Something like this demo. And now I can get that project. I go to IntelliJ IDEA and open, and I go to my download section and open the demo, right? So now my Spring Boot project is up and running. So if you have a community edition, that whole interface is available here. Project, go to Spring Initializer. Let's called, you can see server. You can, let's say if you are on an organization and if you use a different initializer, you can provide the URL as well. Let's call it demo. Let's keep it, and location is this. Let's use the Java Kotlin and Gradle Kotlin. Let's use the com dot Hariya Rajesh, something like this. Hariya Rajesh. Artifact is demo. Package is this. What is the JDK? Let's use Temurin 17. Java is 17 and packaging is ZAR. So let me create on next. So now what dependency I will need? I'll need a basics of the web, right? Spring Web. I can see the description as well. Let's go with the Spring Web and Spring Boot. Let's go with the Spring Boot dev tools as well. So what this does is basically it provides support for restarts, live reloads, and all of these things, which is very helpful in while development. So, and this is a development only dependency. So this will be stripped out when you create your production application, right? Let's select the Spring version as this latest table. And for the simplicity, let's add the PostgreSQL driver as well. And let's use the JPA as well, Spring Data JPA, right? So we have these 4 dependencies. Let me click on create. So now it will, again, it will download the things. Let me create on a new window. Okay, so now I have created my sample Spring application. You can see. Let me open this demo application. So now it's downloading the Gradle. So now you can see my simple Spring Boot application is ready. Okay, if you go to the demo, source, then main, then Kotlin, we have one file called a demo application. And you can see we have something called a class, and then we have a main function as a program entry point. We have this annotation Spring Boot application. We have this run application, something like this, blah, blah, blah. We don't know what is these things. So basically these things will start a Spring framework and a container that will manage the bean and all of these things. We will see it later. And this annotating our class with the Spring Boot application, that means this is the starting point of our application, and our Spring should use these things as a starting point and then start our application, right? So this is all about today. We will see what is these things refers, what is this annotation, what are because see Spring Boot makes heavy use of the annotation, right? And it has a lot of annotation. We will see all of them, most of them in the latter part of the sessions. We will see what is this run application, what is this annotation, and how to run the application, how to handle the network request responses, all of these things in the upcoming days. Okay, with that being said, we are on time, so it's a 10:36. So I'll stop here for today. If anyone has any question, you may ask so, or otherwise we can wind up the session. We will see how to run these things and how to write another code. So basically from the tomorrow we will start writing our code. Okay, so today was mainly focus on the theoretical part. So from tomorrow we'll see how to write the code and how to run our first application. Okay, I can see Akshay has question. Yes, Akshay.
Can we use community edition itself but without auto suggestion?
Yeah, you can use community edition without auto suggestion. If you write the codes manually, that's fine. You can use the community edition.
Okay. That's it then.
Okay, great. Yeah, Nikit, next. Please.
Rajesh, can we use Spring Tool Suite? I mean, ID. I think that would be better if we use that.
Sorry.
Spring Tool Suite, STS, ID,
Yeah.
and ID.
Spring tool shoot, right? So you can do that as well. Spring tool suite IDE is an IDE to develop Spring application. It's an Eclipse based development environment as well. It provides a ready to use. I think you are asking this in context of instead of using IntelliJ, use the STE, right?
Right.
STS, right? Yeah, so you can use that as well, but I don't have much experience with this STS. And again, I believe it has a good support for the Java only. I'm not sure about the Kotlin because you can see it's based on the Eclipse, right? Eclipse ID. So I believe it will have a nice support for the Kotlin, sorry, Java, but not sure about the Kotlin. So that's why I suggested the IntelliJ.
Okay, fine.
Yeah, okay, thank you. Okay,
Rajesh,
Akshay
so
has,
sorry.
yes, Srikant.
Apart from this starter thing which you showed us, right? So
Yeah.
this is the only advantage between the community edition and the ultimate edition. Are there any more features that will
No, no,
help
no, no,
us
no.
during the development?
See, the starter thing is part of the Spring, and this community and ultimate edition is a part of the IntelliJ. I think
Yeah,
you are
got it.
mixing the things up.
No, no, no. My question was, so like in the Ultimate Edition, like we get all those dashboards where we selected like what are the dependencies we required inside the IDE itself. But in case of Community Edition, we went to that starter wala
Right,
project.
right, right.
We made all those settings, download that as a zip file, and then upload it in the Community Edition, right? So apart from, like, is this the only advantage what ultimate edition provides, or is there any other advantages that will provide us
Yeah,
during the
yeah.
development also?
Okay, got it. Yeah. So yeah, definitely this is not the only advantages, because if it's only advantages, then there is no use of using the ultimate, right? So yeah, there are lots of advantages. If you are developing your application, it has a annotation, good annotation support as well. Let's say if you define some beans and some configuration, we'll see that things later. If you use some components, so IntelliJ IDEA can highlight that, okay, where are you using these things? What is the use thing? If you created some API, let's say some endpoints, REST endpoints, so IntelliJ will show some gutter icons here, and you can quickly run your uh, request as well. So yeah, definitely there are a few things that will help you during the development, that will simplify your development experience. But it's not something like that you cannot build Spring project on a community edition. Basically, ultimate will enhance your experience.
Got it, got it. Thanks.
Okay, any more questions on this? Okay, Akshay, do you have any question? I can see your hand is raised.
Oh, no, nothing. I forgot to underwrite.
Okay, no worries. Okay, fine. Okay, so I believe no more question today. If so, we can wind up this session, and tomorrow we'll see how to run our first Spring Boot application, as well as we will jump into the coding part, because we are coders, right? We we shouldn't be only deal with the theoretical part. So we will learn theory as well, but we will definitely move on to the coding part starting from the tomorrow. Okay, with that being said, let's wind up this session. Thank you everyone for joining, and uh, and 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 have a good day, and we will meet tomorrow. Okay, thank you, bye bye, have a good day.
Thanks, Rajesh. Bye.